You know, we interact with code every single day, but have you ever stopped to think about what it really is? Today, we're going to peel back the layers and look at the fundamental DNA of programming, and we'll be using one of the most popular languages on the planet, Java, as our guide.
All right, let's dive right in with a super basic question. How does a computer actually hold on to information while a program is running? I know it sounds simple, but this is the core problem that every piece of software has to solve.
See, deep down inside, a computer's memory is just this massive, sprawling list of raw numeric addresses. Can you imagine if you had to tell your program to store the player's score at 0x7FFC9A44B3B4 every single time? It would be an absolute nightmare. Nobody could do it.
So, this is where programming languages do something absolutely brilliant for us. They hide all that crazy complexity. Instead of us having to remember that cryptic address, we get to give it a simple, human-friendly name, like user score. The computer takes care of linking that name to the number behind the scenes. It's this amazing abstraction that, honestly, makes programming possible for us mere mortals.
So, this simple act of putting a name on a memory location, well, that's our first and most fundamental building block. We're making the leap from those confusing addresses to the simple, powerful idea of a variable.
And that's all a variable is, a nice, easy-to-remember name for a spot in memory. Think of it like a labeled box, a container for a value. And just like the name says, the information inside that container can vary. It can change while the program is running.
You know, a perfect way to think about this is that it's just like using contact names on your phone. I mean, you don't memorize your friend's 10-digit number, right? Of course not. You just know their name. The phone, or in our case, the computer, handles the rest.
Okay, so we've got these named containers, but now we need to talk about the rules. What can we actually put inside them? This is where we really start to define our building blocks.
And those rules, they're called data types. A data type is so important because it tells the computer two critical things: what kind of value a variable can hold, and what you're allowed to do with it. It specifies exactly what kind of brick we're building with.
And in Java, you've got a few main players. An int is for your whole numbers. Got a number with a decimal point? That's a double. Need a simple true or false? That's a boolean. A char is for just one single character, and a string with a capital S is for a whole bunch of characters, like a word or a sentence.
So why even bother with all these types? Sounds like extra work, right? Well, it boils down to three really key reasons. First, memory efficiency. Telling the computer you just need space for a small whole number saves a lot more memory than a super high-precision decimal. Second, error prevention. The system can literally stop you from, say, trying to store your name where a number is supposed to go. And third, valid operations. The type tells the plus sign whether it should be doing math or if it should be joining two bits of text together.
So how do you actually use one of these things? It's a really simple two-step dance. First is declaration. That's where you create the container and give it a name and a type. The second step is assignment, where you actually put a value inside that container.
But, programmers are all about efficiency, so to save a bit of time and space, you'll almost always see these two steps squished together into one single line, just like this. Int user score equals 100. That one little line does it all. It creates the integer variable called user score, and it puts the value 100 inside it. Boom. Done.
All right, so we have our blocks. Now we need to actually start putting them together into instructions the computer can follow. And to do that, we have to understand the difference between a statement and an expression.
The easiest way to think of a statement is like a complete sentence. It's one full, complete instruction that you're giving to the computer. And in Java, that little semicolon at the end, that's your period. It tells the computer, okay, this command is finished, move on to the next one. An expression, on the other hand, is a piece of that sentence that gets calculated. It's a part of the code that boils down to a single value. It could be as simple as the number 5, or it could be a really complex formula, but it always results in just one final answer.
This example right here just nails the difference. The entire line, that's the statement. It's the complete command. But see that little part that says base score plus 100? That's the expression. The computer figures out the value of that expression first, and then the statement uses that result to update the final score variable.
So, to make sure the code we build is solid and, doesn't fall apart, we have to follow a few essential rules of construction. These are all about how we name things and how we make our code safe and easy to read. Now, naming your variables isn't a free-for-all. There are some hard and fast rules. You can use letters, numbers, and underscores, and you have to start with either a letter or an underscore. But you absolutely can't use spaces or start with a number. If you break these rules, your program just won't work. Simple as that.
And here's a big one, something that trips up new programmers all the time. Java is case sensitive. This means my score with a capital S and my score with a lowercase s, well, to Java, those are two completely different variables. So consistency is absolutely key.
You also have to be careful not to use Java's own vocabulary. These are called keywords. They're reserved words like public, class, or int that have a special meaning in the language. You just can't use them for your variable names because it would totally confuse the computer.
Now, so far, we've mostly talked about variables, things whose values can change. But what if you have a value that should never change? That's when you reach for a constant. Its value is locked in and can't be modified after it's been set. So how do we make one? Easy. A constant in Java is declared with the keyword final. When you write final double pi equals 3.14159, you're basically making a promise. You're telling the computer, hey, this value is locked. Don't let me or anyone else mess with it. It adds a fantastic layer of safety and clarity to your code.
All right, let's do a quick recap of the journey. We learned that variables give us human-friendly names for memory. Data types set the rules for what can be stored. Statements are complete computer instructions, while expressions are the calculations inside them. Naming rules and keywords give us structure, and constants, using that final keyword, create values that can't be changed. Oh, and a critical rule to always remember, a variable has to be given a value before you ever try to use it.
And that leaves us with one final thought to chew on. How do these really simple ideas, giving names to boxes and having rules about what goes inside them, how does that scale up to create all of the incredibly complex software we rely on every single day? It's truly mind-boggling how these tiny fundamental building blocks combine to create everything from the apps on your phone to global financial systems.